and Cbse 10th standard for mathematics and science. So in the previous session of quadratic equations, we had derived the formula to find the roots of a quadratic equation, that is x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So that was called as the quadratic formula. So here, for the quadratic equation in the form of ax square plus bx plus c, so this method for finding out the roots of a quadratic equation is the universal method. So here, any quadratic equation roots can be found out by using this quadratic formula. This is very important method. So in the textbook he has discussed two ways of applying the formula and finding out the roots of a given quadratic equation. So in the first method we are going with the generalized method. So you will be given a quadratic equation and you will be asked to find the roots of that given quadratic equation by using formula. So general method I am going to do this. So in the next second type I will be using the concept of discriminant to find out the roots of a given quadratic equation, which I am going to teach you in the next session, right? So in today's session we have a very beautiful question here. Find the roots of the quadratic equation by using formula. So you have to remember or recall the formula here. So I hope you have enjoyed the entire derivation. So you know the formula, you know the square roots plus or minus sign but divided by 2a. I hope you know how you got it at the end, right? So here we have a quadratic equation, that is 3x square minus 5x plus 2 is equal to 0 is the given quadratic equation. You have to find the roots of this given quadratic equation by using the formula method. So in the examination, if he has specifically mentioned that you have to find it by using formula, you have to do the same thing. If he has asked you to find out the roots of the given quadratic equation by factorization, you have to do the same thing, right? Okay. So now, before entering into the problem here, you have to check whether the given quadratic equation is in the standard form or not. So the given quadratic equation is in the standard form, that is ax square plus bx plus c is equal to 0, where the variable x is in the decreasing order of its exponential power. So here x we has 2 as the power, x has 1 as the power here, and we have the real constant. So and the entire equation is equated to 0. So therefore it is in the standard form, right? So here, as the quadratic equation involves, as the quadratic formula involves variables, that is terminal terms like a, b and c. So here you have to extract the values of a, b and c from the quadratic equation, right? So that is the coefficients. The coefficient of x square you have to extract, coefficient of x you have to write, the value of c you have to write, and then we will apply the formula, right, and reach the roots. Okay. So 3x square minus 5x plus 2 is equal to 0 is the given quadratic equation. Now let us write the coefficients. So here coefficients are one is a is equal to, so which is a, this is a, so it is in the form of ax square plus bx plus c is equal to 0. So in place of a, that is we have 3, that is plus 3, so 3, and in place of b we have minus 5. So b is minus 5, so b is equal to minus 5. Here the coefficient of x is b and the coefficient of x here is, with the sign you have to write the coefficient, that is very important. So b is minus 5 and c is equal to 2. Right. So this will fetch you half a mark here. Right. If you write the coefficients correctly, then it's considered that you got half marks here. So if you are right here, then the next process, next steps will be computational, that is steps will be right. So you should be very careful here. Okay. So the roots are given by, very simple. We have to write recall the formula here. So x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So this is the quadratic formula, right? So here we consider that the variable x it is used here. So therefore we have to use x here. So and also you can write here x is equal to x if you want, because I am mentioning what type of variable is being used here. For example, if you had 3y square minus 5y plus 2 is equal to 0, then you have to write x is equal to
Y.
That's all, very simple. So x is equal to, here in the formula itself we have minus. So write that minus, open a bracket, now substitute the value of b. So b is minus 5. So here is a point where most of the students do a simple error, right? So you be careful. So write the minus sign of the b, open brackets, write the value of b inside it. Plus or minus square root of b square. B value is minus 5, so it is minus 5 whole square minus 4 into open brackets. Open brackets. So 4 into a is 3, very good, into c is 2. Okay, 2 by 2 into a, that is 2 into 3. A value is 3. See, this is one of the safest method and errorless method of doing this, because many students I see during evaluation, they write it like this: 4 into 3 into 2. This is not the way, because that becomes, after some time, now you have written it as 4 into 3 into 2, after some time you will write it as 4.32. See, these are all the silly mistakes what we have observed during evaluation, I am telling you, right? So please keep the values of a and c inside brackets. Okay. So x is equal to, now minus into minus,
Plus.
very simple, plus 5 plus or minus square root of minus 5 whole square.
25.
So it is minus 5 into minus 5. So minus into minus is plus, 5 5s are 25. Right. So it is 25. Okay. 4 into 3 into 2. 4 3s are 12, 1 2s are 24. So it is minus 24 divided by 2 3s are, it is 6. Right. Very good. So x is equal to, okay, 5 plus or minus square root of 25 minus 24. 1 by 6. Okay, right? So x is equal to 5 plus or minus. So most of the students, they forget that square root of 1 is 1. What is square root of 1? What is square root of 4?
2.
Square root of 9?
3.
Similarly, 1 is a perfect square. So square root of 1 is?
1.
That's all. Write 1. Most of the students, right, I have seen them, they come to me, sir, here you have put this root symbol, here you have missed it. See, these things happen, right? So 5 plus or minus 1 by 6. Now, from here, the problem is going to take two paths. So you are ready to get into two roots at this point. So x is equal to 5. Out of plus or minus, take plus. 5 plus 1 by 6, or x is equal to 5 minus 1 by 6. This is how you get two roots, right? So x is equal to 5 plus 1 is 6 by 6, right? Or x is equal to 5 minus 1 is 4 by 6. So 6 and 6 cancels. So x is equal to 1. Or right here, 2 2s are 2 3s are. So x is equal to
2 by 3.
2 by 3. So here these are the two roots of the quadratic equation. 3x square minus 5x plus 2 is equal to 0. If it was a quadratic polynomial, right, these two are, if it is a quadratic equation, these two are called the roots of those quadratic equation, of that quadratic equation. If it would have been a quadratic polynomial without equal to 0, then these two are
zeros of the polynomial.
Exactly. So these two become the zeros of that polynomial. Right. Okay. So write the statement. The roots are x is equal to 1 and x is equal to
2 by 3.
3. Right. So this will give you 2 marks. Right. Okay, let us get into the second problem. X plus 1 whole square is equal to 2 into x minus 3. Actually, this is an equation. We do not know whether exactly it is gives us a quadratic equation or not. So we will come to know regarding that when we simplify this equation and reduce that to the simplest form. Right. So let us get into this. x plus 1 whole square is equal to 2 into x minus 3. So it is in the form of a plus b whole square. So which can be written as x square plus 1 square plus 2 into x into 1. That is a square plus b square plus 2ab is equal to 2 into x,
2x
2 into minus 3.
minus 6.
Okay. So let us simplify this. X square plus 1 plus 2x is equal to 2x minus 6. Okay. So here x square plus 2x plus 2x on both the sides, they get cancelled. So that can be done. So remaining is x square plus 1 is equal to minus 6. So we can transpose this to the LHS. So that becomes x square plus 1 plus 6 is equal to 0. So x square plus 7 is equal to 0. So now what is to be done? So it is not in the form of ax square plus bx plus c is equal to 0. So if it is not in that form, here the variable x, that is the variable x, exists in degree 2 only. So in a quadratic equation, if the variable exists in degree 2 only, then it is called a pure quadratic equation, right? So therefore, as it is a pure quadratic equation, we have to transpose the constant to the RHS and take squaring on both sides. Square root on both sides. Okay. So x square is equal to minus 7. So square root of x square is equal to plus or minus square root of minus 7. Square and root cancels. So x is equal to plus or minus square root of minus 7. So here we have got the value of x as plus or minus square root of minus 7, where inside the root symbol we have minus, that is a negative integer. So therefore these type of numbers, they are called as complex numbers, and in the sense the value of these numbers will be complex or imaginary. So this is what I expressed with you in the last session. So for all the quadratic equations we do get the roots, no doubt in that, but for certain type of quadratic equations we do not get the roots. That is, the roots of the quadratic equation do not exist. So this is an example, just I wanted to show you where the roots of a quadratic equation do not exist. So here we can write this. The roots of this given quadratic equation do not exist. Right? So at last you can write it. Roots of given quadratic equation do not exist. Right. Okay, let us get into the third problem. So again we have an equation here, 2y square plus 6y is equal to 3. Right. So 2y square plus 6y is equal to 3 is the given quadratic equation, but it is not in the standard form. We have to convert this into the standard form just by doing a very simple step. That is, we have to transpose 3 to the LHS so that the entire equation is equated to 0. So 2y square plus 6y minus 3 is equal to 0. So now this is in the standard form. Now we will compare the coefficients with the standard form. So coefficients are a is equal to 2 because this is in the form of ax square plus bx plus c is equal to 0. So coefficients are a is equal to, in place of a we have 2, b is equal to 6 and c is equal to -3. Yes, it is very important. Right. So we write the quadratic formula. The roots are given by right. So x is equal to -3 plus or minus square root of b square minus 4ac by 2a. Right. So in the place of x we have the variable, it is changed.
Y.
So this is y. So therefore y is equal to minus. Put the minus, open the brackets. So b value is 6 plus or minus square root of b value is 6, b square 6 whole square minus 4, this 4 into A. A value is 2 into C value is
-3.
right, exactly. So by 2A, that is 2 into
2.
A is 2. Right. So this is the collection of data, this is the formula, this is the substitution. So whenever we are doing formula oriented problems, first we have to collect the data perfectly, apply the formula, and then we will go with the substitution step. Substitution. So substitution is also very important. After that comes the simplification, and at the end we come across the solution. Right? These are the 5 steps involved while solving that is formula oriented problems. Right? So x is y is equal to, so here inside the brackets we have plus, minus into plus is minus 6 plus or minus square root of 6 square is 36. Now be careful, because in the formula we have minus, and for a particular term, that is C, we have minus. So multiply the signs first. Minus into minus is plus, we will write. So 4 2s are 8, 8 3s are 24 by 2 into 2, that is
4.
okay. So y is equal to minus 6 plus or minus square root of 36 plus 24. Plus 24.
60.
Okay, 60 divided by 4. Okay, so y is equal to minus 6 plus or minus. You have to convert 60 into 2 numbers. That means you have to write 60 as a product of 2 numbers, such that among those 2 numbers, one number should be a perfect square. So which particular number suits? Twelve 5s are 60. 12 5s are 60. 12 can be written as 4 into 3. 15 into, yes, 15 into how many times gives you 60? 15 fours are. So one of the chance, because 15 into 4, 4 is the perfect square, right? This is how you have to choose. So inside the square root, look at the number and write it as a product of 2 numbers, such that among those 2 numbers, one should be compulsory a perfect square. So I choose 12 into 5, 60. 12 can again be written as 4 into 3, right? So 3 remains. So 15 into, that is 15 into 4 becomes 60, right? So this can be written as 15 into 4 by 4. Okay. So y is equal to minus 6 plus or minus. So here this square root can be put up like this. That is square root of 15 into square root of 4. This can be written like this actually, right? So when we write like this, square root of 15 remains the same, but whereas square root of 4 becomes 2, right? So that 2 I am going to write here, and square root of 15. So many speak like this. 4 comes out, it becomes 2. When 4 comes out of the square root, it becomes 2. So that's not the method actually. So square root of 15 into 4 can be written as square root of 15 into square root of 4. Square root of 15, as it is not a perfect square, it remains the same. Square root of 4 is 2. So 2 into root 15 is 2 root 15. That's how it comes. By 4. Right. So now, many students, better word is most of the students, what they do, to ones or to twos are, they just divide it. See, you are not supposed to do it, right? So in between the terms, when you are having plus sign or minus sign, and you are having a monomial at the denominator, you are not supposed to cancel any term. That is, 2 2s are 2 1s are, you are not supposed to do it. 2 2s are 2 minus 3s are, you are not supposed to do it, because in between these 2 terms you are having plus sign or minus sign, whatever it is. Here we have both. In some cases, when you come across plus sign or minus sign, that becomes a binomial. You are not supposed to cancel. So then what is to be done? Very simple. You have to take out a term which is a common, that is factor of both the terms. 2 and 6 we have here. We cannot do anything with root 15 because it's an irrational number, right? So search for a number where you can take out common here. 6 and minus 6 and 2 we have. We can take 2 as common. That is a HCF. So we can take 2 as common, that becomes When you take 2 as common here, it becomes minus 3 because 2 into minus 3 is minus 6 plus or minus. Already we have taken 2 as common, so nothing is left in means 1 is here. So root 15 by 4. Now you do cancel that. Now you can cancel it. So it is 2 ones are 2 twos. Now you can do it because in between these two terms you have multiplication sign here. Right? Then you can do it at this moment. So y is equal to minus 3 plus or minus root 15 by 2. So nothing can be done here. Just we will get into writing two roots. Right? So here from here we are going to write two roots here. One is y is equal to minus 3 plus root 15 by 2. This is one of the root. Or y is equal to minus 3 minus root 15 by 2. So this is another root. Right? I hope you got it. So here these two roots, what we have got that for that particular quadratic equation, they have an irrational number inside it. So therefore they are called as irrational roots. They are called as irrational roots. Okay, alright. So there are certain conditions to get an irrational root for a quadratic equation. There are some other certain conditions for a quadratic equation to get a rational roots. So we will discuss when I speak about nature of the roots. Right? Okay. So let us get into the fourth problem. So a given quadratic equation is given here. M square minus 2m is equal to 2 is the given quadratic equation. But we can see a limitation here because it is not in the standard form. So bring it to bring it to the standard form, we have to transpose this plus 2 to the LHS. Right. So m square minus 2m minus 2 is equal to 0 is the quadratic equation. So let us, comparing with the standard form, let us write the coefficients. So you can also do like this, comparing with ax square plus bx plus c is equal to 0. Coefficients are a is equal to, when you compare this with the standard form, in place of a we do not find anything here. Right? So it is understood that a is equal to 1 and b is equal to minus 2, b is equal to minus 2, c is equal to minus 2 and x is equal to okay, very good. X is equal to right. So the roots are given by very simple. Right. So x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So x is m is equal to minus, write this, open the bracket, b value is
minus 2.
Oh, very careful, right, plus or minus square root of b square
Minus 2 whole square.
minus 2 whole square minus 4 into a is 1 into c is
Minus 2.
minus 2, right, by 2 into a, that is 2 into
1.
a value is 1,
1.
right. So this is collection of data, formula and substitution. So now we will go with simplification. So m is equal to minus into minus 2 is plus 2, that is 2 plus or minus square root of minus 2 whole square is minus 2 into minus 2, that is 4. Okay, right, we will multiply the sign, minus into minus plus 4 ones are 4 twos are
8.
very good. 4 plus 8 divided by 2. Okay, so m is equal to 2 plus or minus square root of 4 plus 8 is 12 divided by 2. So you have to convert or write 12 in such a way that, right, it's a product of two numbers. It should be a product of two numbers where one of the numbers should be a perfect square. Exactly. So m is equal to 2 plus or minus 4 into 3. So where 4 is a perfect square by 2. Right. So m is equal to 2 plus or minus square root of 4 into square root of 3. Square root of 4 is 2 to root 3 by 2. So m is equal to, here we have 2, in this term we have 2, in this term we have 2, we can take 2 as common. So we are left with 1 plus or minus square root of 3 by 2. So here 2 into 1 is 2, 2 into root 3 is 2 root 3 by 2. So 2 and 2 gets cancelled, right? So we are left with m is equal to 1 plus or minus root 3. So therefore m is equal to 1 plus root 3, one of the root, or m is equal to 1 minus
root
3, another root. So these are the two roots. So here we can see irrational numbers inside the roots, therefore these roots are called as irrational roots. So that quadratic equation has irrational roots. Right. Okay, let us get into the fifth problem, I hope. Right. So a quadratic equation is given and already it is in the standard form. Right. Let us compare the quadratic equation with the standard form and write the coefficients. So comparing with, that is x square minus 2x plus 1 is equal to 0. So comparing with ax square plus bx plus c is equal to 0. Coefficients are, now let us compare this. This is the standard form of the quadratic equation. This is the given quadratic equation. Compare here. Coefficients are a is equal to,
1.
in place of a we have
1.
a is equal to 1, b is equal to
Minus 2.
c is equal to 1 and x is equal to x. Right. So the roots are given by, right, x is equal to minus b plus or minus
Square
square root of b square minus 4ac
by 2a.
Okay. So variable x is x itself. So x is equal to minus, write the minus sign, open the bracket. B value is
Minus 2.
Be careful. Plus or minus square root of b square.
Minus 2 whole square.
Minus 2 whole square minus 4 into a.
1.
A is 1 into c. 1. Okay. Divided by 2 into a. That is 2 into
1.
Right. So this is collection of data. Formula substitution. We'll go with.
Simplification.
And then we will reach.
Solution.
Right. Exactly. So x is equal to minus into minus 2.
Plus 4.
Plus 2. Minus into minus 2 is plus 2. Okay. Plus or minus square root of minus 2 whole square.
Plus 4.
Minus 2 whole square is 4.
Plus 4.
Okay. Plus 4 here. Minus we have 4 into 1 into 1 is
Minus 4.
minus 4 divided by 2 into 1 is
2.
okay. So x is equal to 2 plus or minus square root of 4 minus 4 is 0 by 2. Right. What is square root of 0? 2 plus or minus square root of 0 is 0 by 2. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 0 is 0. Right. So x is equal to, problem gets into two ways. So x is equal to 2 plus 0 by 2 or x is equal to 2 minus 0 by 2. So 2 plus 0 is 2 or 0.
2.
Right. So if nothing is added to 2, what remains? 2. If nothing is added to 2, what remains? 2 remains. Right. So x is equal to
2 by 2.
2 by 2 or nothing is taken from 2, what remains?
2.
Exactly. So x is equal to
2
2 by
by
2.
2.
So it cancels. So x is equal to 1 or x is equal to 1.
1.
Right. So here you can observe the uniqueness of this problem. So for this quadratic equation we have rational roots, that is they are in the form of p by q, rational roots, and also they have become equal to each other. So in the last 5 problems we have solved different quadratic equations. Now you can observe that in the first problem you got rational roots In the second problem you got irrational roots with a denominator. Sorry, in the second problem you got a complex roots, that is imaginary roots. In the third problem you got again an irrational root but with a denominator. In the fourth problem you got again irrational roots without a denominator. In the fifth problem you have got equal roots. So these are all the different possibilities for a quadratic equation to get the roots, right? So in the next session I will be going with the most important topic in quadratic equations, that is discriminant of a quadratic equation, right? So until that, stay home, stay safe and keep learning. Thank you.